Thank you guys all for being here. I know we're the last session before lunch, but I promise it's going to be worth it. I was really intrigued that Nicole asked me to lead this of all sessions because I didn't really think of design as being a topic really in my wheelhouse. Back in grad school, I did a project where we were designing water filtration systems for subsistence Tanzania, and our team had 2 MBAs who, honestly weren't that useful in the field. Let's be real. And we had 2 engineers, and we had an industrial designer. And the industrial design student, we acted like we were totally separate functions within the team. And I think that is pretty accurate in a lot of our engineering experiences, that we think of design as being product-centric and very focused on whatever its particular field is, whether it's industrial or product or graphical design. But as we're seeing technical fields become increasingly merged, electrical and mechanical and biomedical, the lines are less and less clear, and that's starting to happen in our business functions as well. So design is starting to be applicable and highly desirable if you're in business, if you're in technical design, or if you're solving social problems. And that's a way of thinking that certainly was new to me, and I had to spend a lot of time reflecting on it before I came up here and talked about it. But fortunately, we have a panel of people who have really looked at how to integrate design and to apply it to your career and the world that you want to live in and how you want to affect society. So these are pretty big topics. I'm glad we've got some people here to help us out. And they've got really sweet bios, so I've got cards. I couldn't go outside all morning because I was afraid I'd sweat on these and wouldn't be able to read them. But we have Natalia Baklitskaya, who is a CAD infrastructure software engineer at Intel. And there she is shaping the development world for Intel's hardware and software design engineers by creating tools to automate everyday tasks and creating web portals that are enhancing the productivity and giving structure to their hardware design process. She also works to promote women in tech at all levels and across all the fields. So she serves on the board of IEEE SCV, Women in Intel in San Jose, correct? And she leads some really cool workshops. She's got one this afternoon, and you should check it out. She says if you've got your own laptop, she's got room for a lot of people, so pretty exciting if you're into the flashy wearables, which I kind of am. And then we also have Dr. Terrence Yo, who is an assistant principal director at Aerospace Corporation, which is a federally funded R&D corporation based in LA. And so recently he's been focused on human-centric tech and capability. I did sweat a little bit, sorry guys. And looking at the implications for organizations that want to design efficient and motivated teams that can produce sustainable innovation, not just like one-shot success. So with that, I'll let you guys take it away. Natalia?
All right. Hi, everyone. How are we all doing? Good. Cool. Well, I'm very honored to be given a chance to speak here on this very interesting topic. When I first heard design, my mind very traditionally went to like, oh, design, like for engineering, for work, designing software, designing things like that. And you would think that would be pretty easy for me to just easily go to design automation, which is my field, and pick something from there to talk about today. But Nicole and Gloria really kind of expanded my mind with this because design really does apply to so many different facets of our life. And I picked something that is very close to my heart that I really want to address today. And it's not design automation, which I also love very much. So we're all here at the IEEE Future Leaders Forum. So I'm guessing a lot of us are a little bit nerdy, maybe, a little bit geeky. I'm a little bit myself as well. So a lot of us are probably familiar with the basic fundamentals of electrical engineering. And most of us has probably heard about Ohm's law. So we know that the current follows the path of least resistance. So today, I wanted to talk to you about redesigning the world in which, following the path of least resistance, it is easy for a girl or a woman to end up in a technical field, to stay on that path. Unfortunately, today there's way too much resistance in that current path. There is not enough amplification, and sometimes even diodes in reverse. Just like an inefficient circuit, I think this world requires a redesign. So let's start by first addressing two facets that we can address today, and this is out of many out there. One is expectations, which can be linked to resistance, but could be turned into amplification. And the other one is exposure, which is amplification like crazy. So think of this scenario. A young kid approaches a parent or a teacher or somebody in their community, maybe a family member, and tells them, hey, I want to explore engineering, or I want to join a robotics team, or maybe I want to take a shop class, or something like that. What would the response be if this young child was a girl versus a boy? So think about that for a second. In an ideal world, the answer should be the same for both. Unfortunately, this is not the case in many scenarios today, even though it should be. When I was growing up, girls were ushered off to take home ec class, while the boys got to take a machine shop class and have fun there. And it wasn't really a choice that we had, and our community was guiding us this way. It's not the case for every school, but it is the case in many scenarios. I've spoken to Latina women in engineering who, when they were trying to pursue an engineering degree, were told that they're better off bartending. Yeah. They made it through, though, with stubbornness. And you know, if you check out the toy aisles in many stores today, although Toys R Us is closing down, or even search toys for boys and toys for girls on Amazon, you will see a trend there. You will see more intellectually stimulating toys, more macho toys being geared towards the boys, and a lot of pink and fluffy and cute stuff being geared towards the girls. Although I did see one Lego kit on there, but it was a mechanics shop, so that was kind of cool. In my honest opinion, I think both toys should be targeted towards both genders. Really, it should be a mixture because we need to explore different diverse parts of ourselves. And it shouldn't be so binary. So we really need to redesign the expectations that we have of our young women and maybe put a little bit more amplification on their path and encourage them to pursue these things. It shouldn't, we shouldn't have so many forces going against somebody's path towards a technical field. When you have so much going against you, it is really no surprise that so many people get taken off that path. When somebody you really care about, who you're supposed to look up to and who's guiding your life is telling you or routing you towards something else other than tech, it's quite easy to really stop thinking about it at all. So one way to counter this is to counter the bias within our society and within ourselves. I bet many of you have heard about breaking bias classes so far. Raise your hand if you have. So that's one thing. If you have a brain, you have a bias. It is a given. You can't say, I don't have any biases. The key here is to recognize it within yourself and then to work towards countering it or just recognizing that you could think about things in a more broad way. So there's many companies that are actually teaching these classes now, and you can actually go to one today. Well, it's not a class, but this topic will be addressed in a diversity and inclusion panel this afternoon. My husband, Brian Cover, and his fellow panelists will be talking about this subject. And I think that's the one way you can start today. And by starting with ourselves, we can move on to our community. It shouldn't be an anomaly that a young girl is taking a machine shop class. It should be a totally normal occurrence with no congratulations and nothing like that. It's just like, oh, machine shop, cool. So speaking of shop class, let's talk about exposure. How do you know if you're good at something if you've never even heard of it or tried it? You can't. You don't know. And I strongly believe that every young and curious mind, no matter what gender, no matter what race, no matter what, should be exposed to the joys and fun of engineering. Doesn't mean they should pursue it as their career, but they should be at least exposed. So let me tell you a little bit of my personal story of how I ended up in engineering, how I ended up here. By the time that I started high school, not a single person has talked to me about pursuing engineering, about engineering as a field, about engineering something I could study or even be interested in or try. I have played with Legos though, so I like that stuff, and I did program my TI 83 Plus Silver Edition. But I was strongly headed towards biology and chemistry. And it was really by random luck. I was walking around the hallways in my high school, my freshman year, and I came upon 2 posters. One was a photography class, photography club, and the other one was a robotics team, First Robotics. So you learn how to take really nice photos, learn about materials, metals, machine shop, electronics. Both sounded pretty interesting, but in the end, I was really intrigued by robotics. I wanted to give it a try. I've never heard of anybody talking about it to me to go and try it, but I thought maybe this is something that could be really fun. Well, for the next 4 years, I really got to enjoy myself doing mechanical as part of our robotics team, exploring many different aspects of engineering, because for First Robotics, it really is like different facets of engineering coming together. Electrical, design, machining, programming, all kinds of stuff. I got to cheer for our robots in stadiums filled with us nerds, and it was so much fun. I've got to hear from companies actually talking about careers in engineering. I got role models like Dean Kamen, who started First Robotics and invented the Segway. I've got to hear from founders of Google. I got to hear about the scholarships and all these opportunities. Now, I was still on my track for biology and chemistry, but then by the time I reached my senior year and it was time to choose my major, it kind of hit me. Hey, why don't you actually take this hobby of robotics and combine it with what you're interested in? So instead of applying for biology and chemistry, I started applying for biomedical and chemical engineering with an open mind that I actually might like something else in engineering as well. Well, after I made it to Columbia University, I met this amazing professor, Valancourt, if any of you have ever heard of him, because he's awesome and crazy. And I fell in love with electrical engineering and never looked back and stayed on that track. I had a ton of support there, and I truly loved it. So it was because of this exposure that I received through First Robotics, because of these mentors who took the time out of their day to actually come and mentor us kids in our high school, because of all this community coming together, and even one person just saying, hey, engineering is fun, you should look at scholarships, you should look at the degrees. That's why I ended up actually pursuing this path. Had I not found those posters my freshman year, none of this might have been here. I might not have been part of IEEE, which would have been very sad. So this is why I teach my Maker's World workshops. This is why I go out of my way to go and teach young high school girls and even younger about the joys of circuits and code by using Arduinos, by using wearables to just get them excited and get them to try that out. Again, I don't believe that every single girl should be pursuing engineering or should be excited by it. But I do believe that she should have at least a choice, at least an idea that this exists out there. And I think every young mind really should. Another great thing about trying something hands-on is that then it doesn't seem so scary after all. It doesn't seem so difficult or out of reach or too hard. When I went back to my high school after I started working at IBM, to talk to the high school students who are picking their majors, I got this overwhelming response about engineering. It's too hard. I can't do this. This is coming from kids who go to Brooklyn Tech, a specialized science high school. Clearly, those kids were not a part of a robotics team. Because once you try those things hands-on, it truly makes a difference. Of course, I talked to them and tried to persuade them otherwise. But nothing quite beats that exposure of trying it out, even for half an hour. When I teach my classes to the young high school girls, a lot of the girls, not a lot of them actually, some of them, when confronted with a technical task, like coding their circuit, will tell me, but I don't program. And I tell them, but now you do. And then, in an hour and a half, they crank out 3 projects, circuit and programming, done. And maybe next time somebody tells them that engineering is too hard, they might think otherwise. They might think not at all. And they might actually consider engineering as their degree going forward. So my Maker's World workshop that I'll be teaching later today is kind of centered around the same principles. A lot of us are working in high-tech stuff, We're pretty out there. But a lot of us are not makers or are even afraid to touch a microcontroller. Not because we're not capable, but because we're scared. We've never done it before. We're afraid of failing. Some of us buy it, and it sits there on the shelf for 2 years. Well, today, if you attend my workshop, the participants will actually get hands-on with stuff. I'm not going to teach you about the principles of electrical engineering, but you are going to touch the tools that it takes to make circuits and to make wearables. And because of that familiarity, the participants are much more likely to go off and make their own stuff, or maybe even take what they've learned in the class and teach within their own community and expose more young minds to the joys and fun of engineering, of embedded electronics, circuits, and code. If this stuff is not so much your gig, that's fine. There's many other things that you can do, and I do implore you to do something. You can go and speak in a school, even for 15 minutes, half an hour, whatever it takes. You can mentor a robotics team. I bet there is one in your community. You don't have to be there every day. Even a little bit counts. Be that role model. Those kids will look at you and they will learn that they can be you and they can also do this in the future. There's many, many things you can do and many ways you can get involved. You can communicate with your local Society of Women Engineers groups, with your local IEEE groups, and many others. So please join me in redesigning this world, because we can, by changing our expectations and by exposing more young minds to the fun and joy of engineering. Thank you.
Thanks, Natalia. Terry, you want to take it away?
Thanks, Natalia. Your message really resonates with my heart. I actually have 2 girls myself. The eldest is 11, and she just finished Pride and Prejudice. Wants to read Sense and Sensibility, is an excellent poet, but she's also really just finished the robotics class, and she's excited. She knows how to do Scratch, and she wants to learn Python and become an aerospace engineer.
Oh, we're going to talk.
So the future is coming. The future is coming. I also have a son, and my son, he's 6 years old, almost 7. And I was running this morning. I was thinking about my childhood and technology. And as a child, I used technology every day to save the world. You know, with my Spider-Man web slinger, I could do anything. And as a scientist, I used focused ion beams like Iron Man, transmission electron microscopes at 300 kV to solve root cause failure analyses for billion-dollar problems in space, so that we can be safer every day. And now as a professional, I'm developing artificial intelligence algorithms to dream new solutions, new ideas, new answers to age-old problems by using very, very limited data sets, much like a child does. And as a child, and as a scientist, and as a professional, I've come to realize that technology is not the solution. I'm going to say that again. Technology is not the solution. Now, here I am at the IEEE Future Leaders Forum. IEEE, a society dedicated toward advancing technology for humanity. And I'm here to say technology is not the solution. Let me give you an example. So in our endeavors in the IBM Watson AI X Prize, our team has been reaching out to international aid organizations to see how we can utilize AI for good. We went to one of these organizations and proposed a solution to take AI algorithms, couple it with overhead commercial satellite imagery, because we're the Aerospace Corporation, FFRDC for space, and provide a solution for illegal activity, particularly poaching events in underdeveloped areas. And the aid agency thanked us for our initiative and shared with us that they have things like Internet of Things trackers on rhinos to be able to understand where they are at any time. They can even give a good idea of when these things are going to happen. They shared with us that technology, and getting that technology to the right hands, is not the problem. The problem is people. People are their problem. Now, that really hit me because I started to realize, what is this about? And we asked them, and they said, Let me give you an example. They said, we can bring technology, find out that poaching event, send it by text message to the game warden. The game warden will say, thank you so much for providing this location. The problem I have is I'm on the other side of the park. I'm never going to get there in time to save those animals. So like the typical engineer, we think, oh, all we need is an advanced transportation mechanism, right? Give them a nice truck, maybe even a helicopter. Until we find out that the reason why the game warden's on the other side of the park is because somebody else has paid him to be on the other side of the park. You see, the design of illegal trade benefits that individual's family, that individual's community, and that individual's society, where doing the right thing doesn't benefit. So the problem is people. The solution is not technology, at least the technology that we understand. Now, technology that we understand today typically goes in a linear fashion. There's a beginning and an end. We have a problem, we develop a solution, we put those things together, boom, we've problem solved, next problem. Much like my daughter doing math problems in a book. I'm done with the book. But if the problem is people, and the solution is not a linear solution, what is that solution? Well, you think about, if people are the problem, we got to understand as a scientist what that mechanics of people, maybe giving that understanding may give us an understanding what the real solution should be. So you think about people. People have, part of this thing called life, right? And the meaning of life, right, has been debated upon by theologians for many years. I'm not going to go into that. But if we understand that, we have a beginning and an end. But there's something in the middle that's really interesting. There is a propagation function. There's an expansion function, a multiplication function, a replication function. And if you look at that from beginning to end, where this thing, when called, calls itself, we understand that, right? That's a recursive function that adapts, that changes, that evolves. Our solutions, though, are linear. Maybe, just maybe, we're using the wrong solutions for the problem. Maybe we should be using a recursive function to solve that problem. We stumbled upon this solution at the Aerospace Corporation, strange enough, in developing an intern program. The intern program we have at Aerospace Corporation is called Tech Talks, Technology, Education, Career. It's a 10-week program run by volunteers that pours in to the next generation of aerospace, the interns that come. Knowing that only a small portion of them will stay with the company, and most of them will go off to other organizations, and it will benefit them. Now, this was started about 4 years ago. We had no intern program, and it was conceived by a vision from an administrative assistant by the name of Sandy Kellenberger. She had the vision for a national intern program. Now, we have about 3,000 scientists and engineers at the company, but she had this vision of not only dealing with the engineers and scientists, but also all of the support staff around there. A couple of us went on to that vision. We had no budget. We had no backing by the corporation. We just knew a few senior managers that would be willing to come down and speak to these interns. Our first meeting, we had 20 interns come. By the middle of the summer, we had 40 interns come. It was a huge success. Today, after 4 years, we have nearly 300 interns that a committee of 20 are pouring into. Now, you see that solution set has all the hallmarks of recursion in that exponential growth. What we found actually inside is that we actually found and stumbled upon a solution for a leadership engine, a very, very powerful leadership engine within the company. And so looking back, we say, okay, how is this designed? How is this made? We found 3 principles. First, an all-volunteer committee. Your compensation is your service, and your service is your compensation. So if you want to increase your compensation, you increase your service. Secondly, you serve for a cause that is beyond yourself, that it benefits somebody else in another group way more than it benefits yourself. And the third one is, if you do the first and the second principle, you generate an incredible leadership engine. In fact, one of the chairs of our Tech Talk program, she recently, with no prior management experience other than Tech Talk service, she was able within 1 year to jump 2 management. She got promoted twice within a year She's now a director of a very important portion of our company, supporting a very important project. So when we see this, and we see that this is a recursive function, right? And if it's a recursive function, then this is not the first time this has ever happened. It's been called on before. And it should be evident in every part of nature and every part of life. And if you think about it, there's a lot of examples. My favorite example is the honeybee colony, right? Only the most senior bees go out risking their lives to find food. So think about that whenever you swat one of these bees. Risking their lives to find food to come back and give to the next generation. The only reason why they're able to do that is because someone else, the previous generation, did that for them, right? So why am I here at the IEEE Future Leaders Forum? Because the problem of people has a recursive solution. The answer is people, but in this case, people of good character, good leadership skills, and good vision. So I challenge all of you today, because we do need leaders in all of our organizations. We need more leaders in our cities. We need more leaders in our states. We need more leaders in our nations. And we need more leaders in our world. So I challenge you, how can, in your organizations right now, create a leadership engine in which you create more leaders than you can handle that can't help but go out and benefit other organizations? Because that's how we're going to change the world. Thank you.
Thanks, Terry. I love having panels like this because it's gives me a really hopeful vision for the future when there are some really dismal days. So thank you guys so much. We've got about 10 minutes for questions, so I'm going to start. If you guys have questions, please stand up. And I think there's a microphone over there that you either can head to it or can you take it to them? All right, cool. So just a really high-level question to start with. What distinguishes design from engineering?
You want me to?
You guys can fight.
I can start, I guess.
Great.
I don't think they should be separate. I think good design is part of good engineering. Let's say we'll take software. You don't think about design maybe much when you do software, but if you're actually going to build scalable, good software that can be maintained, it has to be well designed. It has to be modular, and there's many other different practices that you can pursue that you should really, really think about. Don't just start coding something random. Think about how you're going to really build this thing, what it's going to look like in the future. Vision is a big part of this, so you have to really see where this is going. So I think the two should really be built in together. If you're doing anything engineering, you have to think about design, and you have to think about diverse design too.
Thank you.
I would say engineering is the implementation, execution of a design. I think of engineering as all the nuts and bolts inside, but the design is the why, right? If you have a why of what this product or what this thing, like in my case, Tech Talks, what this thing really is, right? Then you'll know how to work all of the engineering portions of that. So when we started that, we designed in mind, actually, a leadership engine in the beginning. Because when I saw in our company, we had formal, structured ways of leadership development, but we found that there wasn't a way somebody could just raise their hand and says, I want to start working on something. So the great part about aerospace is that it's kind of like a college campus, so you can, if you have a vision, you have an idea, you can just come in and start something. So we started this idea, and it's kind of propagated. We have a couple other groups now that are trying completely different things, but with that same mindset. And the great part is, if you design it right, you can actually separate yourself from that. So myself and Sandy have now fully pulled back from this organization, and it's self-sustaining. It has its own life.
That's great.
So if you design it right, then the implementation, the engineering will work great.
Awesome. Questions from the audience? Shatali, are you out there? I thought you were going to have a question for me. Looks like no. All right. So do you guys have resources or classes or specific experiences that drove your design thinking, or is this something that you've developed independently?
When I went through several jobs in my career, and one of those jobs was at Accenture Labs. And one of the things that we talked a lot about there was design thinking. And so as a result of that, so you can look up design thinking, TED Talks, YouTube videos, and things like that. It would actually be very enlightening because you really do have to think about design in engineering. There is a great book called The Design of Everyday Things. How many of you have heard of it before? It's a good book. So if you haven't picked that up before, it's really fun and it makes you think about the world in a different way too. For software, since I keep going back to that as part of my job, you can look at programming patterns and things like that to educate yourself on how to go about it. And always think about the user experience, because what are we doing this all for? It's people in the end. And for people, design matters a lot. Usability, things like that, maintenance, and like Terry said, stepping away from it. If you design something well, then you can let it live on its own.
I think I really resonate with Dr. Hornbeck's methodology, right? In that we're at an age where we have amazing access to information, to experience, right? If you want to learn how to change a toner cartridge, you just look it up on YouTube, and suddenly you know how to do this, right? So there's a lot of resources out there. I think being broad-based in your experience of other people's experience is very, very crucial, just like when he went upstairs and asked the luminaries of ideas and brought it back down. But in that same sense, I resonate with the going independent, to say, no, I've got all these ideas, I've got all this experience, now I'm going to try something new. And try something new with two things in mind. One, I'm going to go after the objective, but also what are all the fail successful ideas, right? Instead of fail safe, fail successful. If I completely fail on this one idea, what are all the other benefits I get out of this? And other people get benefits out of this. I think if you think in that mindset, there's really no way to fail, and you'll see that design will come on both the bottoms up, where you have certain short-term objectives and then a long-term gain at the end, much like winning a major award from the from the Oscars.
So when working at a small company, I've experienced a lot of pressure to skip design sometimes and push for getting the product out. So I was wondering, have you found yourself in a situation like that, and how do you push for making the leadership understand that design is important and whatnot?
Part of this is having a good manager, unfortunately. So I'm really happy with how my team operates right now. But part of it is also iterative design. So if you are pushed towards a deadline, and I surely have before as well, I have made some stuff where I'm writing it and I'm like, this shouldn't be like this. It really should be structured, pulled out later. Then I actually go and revisit that, and I restructure it over time to make sure that it does adhere to my standards of how things should be and to make it better designed. So make little to-dos for yourself in the code. Kind of have that plan for yourself, that where you will follow up on it. Do talk about it. Do highlight the benefits of a well-designed product that you're trying to make. But in the worst case scenario, and you really have to deliver now, we even have like this project right now that's been going on for some time, and we have to rework the database, but we keep not getting the time to do that because of high pressure to deliver new things. Just make sure you log those things and make sure you demand for that space at some point to do that rework. And do it incrementally. Just do a little bit of time, because in the end, it's all going to come together.
I think that's a really good question in terms of trying to balance, right, those two ideas. It just reminds me of a quote that my advisor in grad school, Jim Coleman, said to me. He said that you can do whatever you want to do as long as you do everything I tell you to do first. Right? So I would give you that answer, is that yes, you've got minimum viable product that needs to be done. and it may look messy. That's the engineering part. But you also have time, like time in a truck, time on the freeway in Los Angeles for 2 hours as myself. And you can think about these things and say, well, what if we could just draw it, clean sheet and say, what would be those ideas, those design principles? Put those in, you can put it down in maybe 1 or 2 different principles, and then work on that slowly. And eventually you may have something that really works, and you go, hey, we've got this little mess, this little rat's nest of code, and I've got this monolithic modular system that I put together on my side. Here you go. And now you've met both of those requirements at the same time.
There's also, to add to this, there is a book called Working with Legacy Code. Many of you might be familiar with it. Any code that's not tested or nicely modular is legacy code, no matter how recently it was written. And it talks about different ways to work through that kind of stuff. Again, going back to software, but this could be applicable to other things as well.
All right, we got somebody else. I'm like a deer in the headlights up here, so yeah, stand up, because I can't see if you don't move.
So I think a lot of us could maybe identify problems in our lives or in our workplace that could be redesigned. How do you find the courage to realize that you're the one that should take that step to redesign something, and just the courage to see it through?
Vision is good. If you have that vision, if you see the problem, who else? If you wait on the sidelines for somebody else to design your world, they might not have the same vision that you have. You might not like the result. We can't keep sitting on the sidelines and expect the world to be nice. We can't complain about the world being the way as it is if we are doing nothing to contribute or change. This is why I started teaching the workshops. If I don't do it, who else will? If we all just sit back and let nothing happen, somebody else is going to take charge. So go for it.
Hi, I have a question. My name is Chetali, and I have a question. When you said that we need leaders, when you talk about leading something, you're talking about managing things. And when you manage something, you're kind of slightly diverted towards managing then technical side. How do you design your career keeping on the technical side and yet being a leader?
No, that's a very, very good question. I think, when I went into management, people ask me, why do you want to do management? And my first answer is, well, I have no idea. But that's a bad answer, so never say that. But I followed up right afterward, and I said that I have achieved all that I can in this very short time period. I've had a lot of mentors to grow into this position. And I could do this for my whole career. I could be extremely technical. I could become a fellow in the company. This is great. But I see the need to create that space so that others can thrive in that environment as well. And so that's, I think, would be that balance, is you will have to leave your technical behind, but you have to know your why. It's not about more money. It's not about influence or power. It's about the ability to create. For me, it's about the ability to create an ecosystem so that many more people who are coming onto that will have that environment and opportunity to be the best technical person they can, and maybe even so desire to leave the things that they love so that others can also enjoy that in the future.
All right, we got time for one more question.
Fantastic remarks. So building off of that for a second, can you talk a little bit more about ensuring multicultural inclusion in that design thinking and design development? Because I think what's been interesting in today's world is we've become more global in nature. We have a multi-generation from baby boomers all the way to digital natives. And on top of that, you've got these fears as design comes into thinking, whether it's our mobile devices or cars or whatnot. You've got this wide range of disparity between those who know how to deal with it and those who are just afraid of it. And so I was just kind of curious, how do you encroach or encourage that kind of multicultural perspective to be there? Or is it even possible? Is there going to be a divide where at some point those has and those have nots will have to happen? I don't.
You want to go first?
I'll go. What I see is, that's a very challenging thing. I see that, again, that recursive function that comes in that we're in, kind of an artificial structure in some ways, right, with society that and especially organizations. But we can also hack the system and utilize very long-standing traditions that are built into our culture, into our being. And one thing that comes out is that concept of mentorship. If you have a senior manager, they love to come to talk to people who are just starting their career and share about their experiences. There's this passing on of knowledge that is very fundamental to our culture, to our people, to our being, how we've been created. And so if you utilize that and get them into that mode instead of, oh, they're the ones who are going to take over my position, to say, no, big picture, I need to give as much time to them as possible before something else happens to me so that the group can continue, so that colony can thrive and prosper. You get that hacked in, it's fairly straightforward, then there's no problems. You get that, you get it all working together. That's my solution.
So if I understand the question correctly, trying to say how to apply technology to the multicultural world so that they can easily integrate with it.
Or so, how do you encourage multicultural thinking into the development of technology?
Mm-hmm.
So for instance, with AI coming online and machine learning and all that stuff, a big issue I've been seeing with my friends in the African American community has been, we're not part of the conversation. So, you develop this, you develop this technology, but it's cute and all. So I did this panel recently at Morgan State University, a historical black college university, and many of the folks that were saying, we're not part of the conversation. Mm-hmm. So we are fearful of the fact that because we're not part of the conversation, when it comes online, we won't be part of it, the solution.
Right. Well, one thing we can do is what you're doing right now, talking about it, bringing it up, because as long as people are not actually voicing this concern, which is a very important concern, that may be ignored. This is why you have diverse teams, to cover these blind spots that other people just might not be thinking about. The engineers very well might be like, oh, let's work on this cool tech solution, and they completely ignore every other aspect, which does include design, which does need to encompass our multicultural world. So talk about it. All of you are in tech. You will be in tech. When you are working in these technologies, do bring these things up. Do bring up the studies. Also, usually it's companies or sometimes universities, but a lot of times companies are very profit-driven. And if you kind of point out that if they miss this little thing here and you miss an entire group of people, their profits might not be so good. Their product might not do so well. There might be serious issues. And I think companies respond pretty well to that usually. I know within our companies this concern is raised and the company is doing something about it, but it really should be like one of the fundamental things that is we're thinking about when we're working on things early on. So talk about it and bring it up.
All right, thank you guys for your questions. Thank you guys so much for your time. I really appreciate all of the effort you guys have put into the talks and the questions. If you guys wouldn't mind giving everybody a big hand, and then we'll do that first.